What is a resistor? A good definition might be this one. A resistor is a passive electrical component with a primary function to limit the flow of electric current. The standard symbols for resistors are given below. The zigzag on the left is the American standard, and the one on the right is the international standard by the IEC. To explain the definition more clearly, we use the example of water that flows through a tube. The flow of water is similar to the electrical current in an electrical circuit. The pressure difference that causes the water to flow can be compared to a voltage difference which causes the flow of electrical current. If we create a resistance in the flow of water, the current will reduce. We can do this, for example, by making the tube more narrow at a certain place. A resistor is pretty much the same. The resistor has a higher resistance than the connecting leads and causes a reduced electrical current. We can see this in the water pipe that a pressure drop is created because of the narrow part in the middle. The pressure on the left is bigger than on the right. The resistor has a similar effect. Here a voltage drop is created. The relation between the electrical current, voltage and resistance is described by Ohm's law. Mr. Ohm was a German scientist that discovered in 1827 that electrical resistance is equal to voltage divided over current. In this formula, resistance is in ohms, voltage in volts and current in amps. A simple circuit with a battery and a resistor can explain this. The voltage source causes a current which is limited by the resistor. The voltage source is 2 volts and we want a current of 4 amps. So what resistance should the resistor have? According to Ohm's law, the resistance is equal to the voltage divided over current, or 2 over 4 is equal to 0.5 ohms. An example of an application of this simple network is a basic LED circuit. Suppose we want to light a red LED with a 9-volt battery. The LED has a specified maximum current of 30 milliamps. If we directly connect the battery, the LED might burn out instantly. The LED practically doesn't create resistance, so the current will get much higher than the 30 milliamps. To prevent this, we can place a resistor at the positive lead between the battery and the LED. The resistor should have a resistance which is just high enough to reduce the flow of current to 30 milliamps. Using Ohm's law again, we know that the resistance is equal to voltage divided over current, or 9 volts divided over 0.03 amps is 300 ohms. If we now connect also the negative lead and create a circuit, the LED emits a nice red light. Using the resistor for an LED circuit is just one application, but there are numerous other applications and purposes for resistors.